right, everybody, let's get started. Welcome to our new course. We're going to be talking about financial maths over the next 6 lessons. And today I want to start with some revision of grade 11 work. As we know in Matric, our grade 11 work is so very, very important. It forms the basis of everything that we get asked in Matric. Plus, we also get questioned on grade 11 work as well. I will point these things out to you as we go along. All right, so we will talk about future value and about present value in time to come, but this lesson really was about compound interest and about reducing balance depreciation, which are two important concepts from grade 11 that get asked in grade 12 as well. Okay, so our formulae for financial maths, this is not just the grade 11 formulae. Simple interest, we all know A equals P1 plus IN. We very rarely get asked anything about simple interest once we get into grade 12. Compound interest. Okay, so A equals P1 plus I to the power of N. Or if we want to calculate P, we could do it this way as well. Why is the exponent negative? Can anybody tell me? Why would that work? Oh, Lihle, Lihlu. Yolanda, please, can you help Lihlu? They can't hear me.
I am helping Lisumelo just now.
Thank you. Okay, so in other words, the reason why you'd have your negative exponent here, Matrix, is because if you want to make P the subject to the formula, right, you would have to divide by the bracket on both sides, isn't it? Okay, so in other words, P would become the subject when you divide A by 1 plus I to the power of N. Remember, you can take a base from the denominator into the numerator if you change the sign of the exponent. So that's why we can write it as A times our base to the power of negative N. Okay, so just remember that because you may end up seeing it at some stage. Okay, straight line or linear depreciation also very rarely gets asked. And very important for us, this often gets asked in Matric, reducing balance depreciation. Okay, so make sure that you know that this is the formula to which they are referring when they talk about reducing balance depreciation. Often they ask us questions, how to calculate the value of N, which is something we'll talk about using logs in time to come, etc., etc. But yeah, that's one of the things I wanted to emphasize tonight was reducing balance depreciation. Another thing they like to ask us in Matric, okay, a throwback from grade 11, is this: how to convert a nominal rate to an effective rate and vice versa. Okay, so this is not on your formula sheet. If you do not learn this formula, you will not be able to answer any questions about nominal or effective interest rates if they ask you. Okay, so make sure that you have learned this formula. Otherwise, you're definitely not going to be able to answer any questions on nominal or effective interest rates. Okay, let's move on and go and have a look at our first example. So they tell us that Craig deposits 65,000 Rand into a savings account, paying 15% per annum compounded monthly. He wants to buy a car in 3 years' time. Calculate how much money will be available to him in 3 years' time if he makes a further deposit of 10,000 Rand into the account 1 year after his first deposit. So what they are implying here is that we need to set up some kind of timeline. Okay, so the first thing that we want to work out, all right, is how many years is this going on for? Okay, he wants to buy the car in 3 years' time. Yes, absolutely. So you can screenshot the questions. Okay, so in part A, All right. How many years is this going on for? It tells us he wants to buy a car in 3 years' time. So we have T0, T1, T2, T3. Okay. Initially, he deposits 65,000 Rand. So we treat that as a plus. Plus 65,000 goes in at T0 at the beginning. Okay. The interest rate is 15% per annum compounded monthly. That doesn't change. From start to end, our interest rate is 15%. That's 0.15. And if it is compounded monthly, then it has to be divided by 12. They say to us, calculate how much money will be available to him in the 3 years if he makes a further deposit of 10,000 Rand into the account 1 year after his first deposit. So in other words, at T1, he is depositing a further 10,000 Rand. Okay, how much money is he going to have in the account? What is A going to be here at the end? Okay, so our formula, A equals P1 plus IN is what we're going to use because we're talking about compound interest. Before we actually make the equation, let's just talk about what these things mean. What does A represent? Yolanda, please help Seketelo. What does A represent? Matrix? What does A represent? The final amount. Cool, Lesedi. The final or accumulated amount. What does P represent? What does P represent? Okay, good, our initial amount. What does I represent? That's it, the interest rate. So remember, that's got to be divided by 100. It's given as a percentage. Excellent. And finally, what does N represent? Number of compounds, paying period, number of years, amounts of years, number of years. A lot of people are saying, okay, so now everybody that's saying that it is the number of years, it's not. Okay, it's not the number of years. We think that because of a misconception that is created when we are taught this in grade 9. Okay, when we are first taught compound interest, then N represents the number of years. That's because the interest is always compounded annually. But remember, when we go into grade 11, they change the frequency of how often the interest is compounded. Okay, so N is not the number of years, it is the number of times. Number of times the interest is compounded. In the period. Okay, so in other words, if the interest is compounded twice a year for 4 years, what's the value of N going to be? If interest is compounded twice a year for 4 years, what's the value of N? Exactly, in Kaniso. Okay, so the money, it's not 8 years, it's the number of times it was compounded. Okay, all right, so very important. When we are working with compound interest, N represents the number of times that interest is compounded in the period. Okay, it is not the number of years, unless, of course, we're working with an interest rate where it's being compounded annually, but you're not going to see that in grade 11 and grade 12 anymore. Okay, all right, so now let's make our equation. All right, so 65,000 Rand goes in. it earns interest at a rate of 15% per annum, compounded monthly. And that 65,000 Rand stays in the account for 3 years. Okay, it is compounded monthly, so it will be compounded 36 times during that period. In addition to this money, he also deposits 10,000 Rand 1 year in. That money stays in the account. It earns interest at the same interest rate, 15% per annum, compounded monthly, but it is not in there for 3 years. How long is the 10,000 Rand in the account for? How long is the 10,000 Rand in the account for? It is in the account for 2 years. Yes. So here we have to say 12 times 2. Okay. So in other words, when you are working with a timeline, you add for deposits, you subtract for withdrawals, and if the interest rate changes on an amount, that's when you multiply by a new bracket. But we'll see that just now. Okay, that's all right, my lady. Okay, so because this is the standard class, I am presuming that you guys understand what it is that I'm doing here. I am obviously not jumping in at the beginning of grade 11. Voyo, ek weet nie hoe kom nie. Let's ask Yolanda to help. Yolanda, please help Voyo. Okay,
Yes.
so cool, thank you. Are there any questions? I'm going to work this out. Is this making sense to you? Are there any questions? Are we all okay? Okay, so everybody's happy. Okay, cool. All right. So that means this guy, excuse me, guys, has got 81,463 Rand and 41 cents after 3 years. Okay. All right, now let's have a look at part B. So Craig then buys the car for the amount saved after the 3 years. He drives the car for 4 years and then sells the car. Suppose that after 4 years of reducing balance depreciation, the car is worth 1/4 of its original value. Calculate the depreciation interest rate as a percentage. Okay. So now, part B. We do not need a timeline for this. So, first of all, they want us to calculate the depreciation interest rate. Okay, so what formula are we using? I'll scroll up and go and have a look at the formula. What formula are we using for this question, guys? Which formula? Go down to the question again. Which formula do we need to use? Reducing balance, quite right. Yes, lovely. Good, reducing balance. Okay, so that is A equals P 1 minus I to the power of N. Okay. Pinga, oh, hang on a second, Pinga. You know what? I've just realized, thank you. You know what, guys? I've just realized I made a mistake on my calculator. I've just seen it now. Pinga, thank you. I had 0,015. Thanks, Pinga. You're quite right. This, sorry, guys, let's just change that. Sorry, I had 0.015 Pinga. That's why. Let's just put that in again. 0.15 this time over 12. Oh, there we go. That's better. Okay. Sorry, guys. It should be here. 115,129, 86. Okay, Pinga, is that the answer you got? Okay. All right. Guys, please, if I make a mistake or you don't get the same answer as me, I'm not precious about stuff like that. Please tell me. Okay, I do make mistakes. I'm not perfect. I try my very hardest not to, obviously, but I don't always get everything 100% correct as well. Okay, sorry. With my previous answer, I'd added an extra 0 in over here, and I had 0,015, and that's why my answer was a bit strange. So my apologies for that. Okay, so back to question B. All right, we know that we are using reducing balance. Okay, it tells us here in the question the reducing balance depreciation formula must be used. And they've told us that they want us to calculate the interest rate. So which letter do they want us to solve for? Which letter are we solving for in this question? We are solving for the I, exactly. So they want us to solve for the I. So if we are asked to solve for the I, that means that we need the others. We've got to have the A, we've got to have the P, and we've got to have the N, okay? Because we can only solve for one unknown in an equation, right? So let's go back and read the information. He buys the car for the amount that he saved after 3 years. Right? So that means that he must have purchased the car for this 115,129 Rand and 86 cents. He drives it for 4 years and then sells it. Right? It's worth 1/4 of its original value. So what does the 115,129.86 represent in the second equation? Is it the A or the P? So remember, be very careful with reducing balance depreciation. Okay, your A has to be smaller than your P. Good, well done. It is what the car was worth originally before it depreciated. Well done, Matrix. You guys are very, very smart. So P over here, we've got 115,129,86. We've got 1 minus I. So now we need the A value. What's the A value? No, Pinky, you don't, unfortunately. It does help you to draw one, but you don't get any marks for it. The only marks that you get are for like this stuff here that I'm drawing the green box around. That's when you get your marks. Usually for something like this, there might be a mark for the first term and a mark for the second term and a mark for the answer, or they might give you one. Sometimes they give you a mark on the exponent. I know when you work with future value and present value, often they give you a mark for the exponent, the number of payments. Okay. All right. Exactly. So it's a quarter of that. So this would be 115,129.86 divided by 4, right? So our A value, 28,782 Rand. And let's make that 47 cents. Okay. Yes, Kamgelo. You're welcome to
Hi,
unmute and speak. Hi, Kamgelo.
how are you, ma'am?
I'm fine, and you?
I'm alright. Ma'am, I would like to ask why are we dividing it? Why are we dividing it by 4?
Why are we dividing what by 4? Oh, you mean why are we dividing P by 4?
Yes,
Okay,
ma'am.
because the car, if you look here, Camgelo, the car is worth, after 4 years of driving it, the car is worth 1/4 of its original value.
Oh,
Okay,
okay,
so
ma'am.
if it's if something, if it's 1/4, if you times by a quarter, it's the same as dividing by 4. That's why we're dividing by 4. Does that make
Alright.
sense to you?
Yes, it does, ma'am.
Cool, lovely. All
Thank
right,
you.
no problems. Okay, and now we need the value of n. Okay, so when it comes to reducing balance depreciation or linear depreciation, the compounding period never changes. It's always an annual rate. Okay, it's always compounded annually. That's because if it was compounded more frequently than that, the things that we buy would be worth very little very quickly. Okay, so in order for things, yes, Tsegofatso, that's exactly it. What he saved up for, that was implied, that was the value of his vehicle. Yeah. Okay, so here, this is going to be to the power of 4. N is going to be 4. Okay, so when you're working with reducing balance depreciation, they do not change the compounding period of the depreciation. It is only once a year. All right, so now we've got to work out the value of I. Okay, so I hope this, but I'm going to do this quite quickly. I hope this makes sense to everybody. We need to divide by P on both sides. So that means that we've got our 28,782,47 divided by 115,129.86, and it's going to be equal to the bracket. After this, to get the bracket without the power 4, we need to take the 4th root on both sides. Okay, so now we've got 1 minus I on the right, and on the left-hand side, let's just get rid of this green block that was here. Okay, so we have got on the left-hand side, I'm just going to write it all out again, the 4th root of 28,782,47 over 115,129,86. And then the easiest thing for you to do at this step here, matrix, is to transpose this negative I over to the left, and what's on the left, bring it over to the right. Okay, so in other words, you are going to end up with I on the left, and on the right, you've got 1 minus your root. Okay, and then your final answer, you've got to remember, because they want a rate, you've got to remember to multiply it by 100. Okay, so let's see what we get here. Okay, iPhone, you are not wrong. I'm getting this. You guys getting the same answer as me? Yes. Okay. So you should be, that's it. Okay, so iPhone, you weren't wrong. You're just rounding it off too quickly or too soon. Okay. Remember, it's always got to be rounded to 2 decimal places. Okay. That's it, Kamgelo. Good job, everybody. Okay, so let's move on. Unless there are any last questions, and go and have a look at something else. Okay, so here again, let's not do linear depreciation. I'm going to try and find something more exciting. Okay, let's do this. Okay. Robin invests 30,000 Rand at 16% per annum compounded quarterly for a period of 15 years. Convert the nominal rate of 16% per annum compound quarterly to an equivalent effective annual rate. Okay, so now you need the nominal and effective interest rate formula. Okay, that's this one over here. I think I highlighted it in blue at the beginning. Okay, so let's just talk about that a little bit. Katlego, go for it.
Ma'am, can you please just go to the previous answer? I just want to check if I'm right. My network is a little bit slow, so I didn't see the answer.
That's fine. There's the one in pink.
So ma'am, we're
Okay.
supposed to multiply it by 100.
100, yes, because they want the rate, the interest rate. So you've got to
Okay.
multiply the I by the 100. Okay.
Okay, ma'am, thank you.
Pleasure, Katlego, no problem. Okay, so our effective interest rate. Okay, Kamgelo, I see your hand is up. And one other. Okay, Kamgelo, go for it.
Ma'am, when we are writing the answer, like, are we supposed to write all the numbers after the comma, or it's okay to just round it off at the beginning, like 0.2, 0.30, or 0.29,
No,
0.29?
no, that's not going to be okay. So the best thing for you to do when you work out I is write out everything, because you actually need to consider the first 5 numbers. Because when you times it by 100, this bit over here is going to be to the left of the semicolon. These 2 numbers over here are going to be to the right, not semicolon, to the right of your comma. These 2 numbers over here are going to be to the right, but then you've got to worry about what this number over here is, the 9 is as well, because it can cause this one to round up. Okay, so make sure you've got the first 5 numbers.
All right, thank you, ma'am.
No problem, so that you can round correctly to 2 decimal places. Okay. All right, so going back to annual effective and nominal interest rates. Okay, so our formula IEFF, that is for our effective rate, is equal to 1 plus I nom over M to the M minus 1. Okay, now, before we get started on this, let's talk about what a nominal rate is and what an effective rate is. Now, this is often something that's quite difficult for us to understand, but it's not meant to be difficult. Okay, does anybody know, can anybody explain to me what you understand a nominal rate to be as opposed an effective rate? Kamgelo, go for it.
Ma'am, I think that like the effective interest rate is like an interest rate that is paid maybe once in a year, and then the nominal interest rate is like paid more than once in a year.
Kamgelo, you are on the right track. Take that off because I'm boiling. You are definitely on the right track with that. That's a really good answer. Okay. Let's just refine what you're trying to say a little bit. Okay. When we are talking about a nominal rate, okay, we will be quoted a rate per annum. So let's say we are quoted 16% per annum. But the way that it is compounded is different. So in other words, the interest is not compounded annually. Let's say the interest, like with this first question over here, it's compounded quarterly. So the interest is paid per annum, but it is compounded quarterly and not annually. That is a nominal rate. An effective rate would be something like this. Okay, let's pretend that you are getting 10% per annum, and now it is compounded annually. So the rate that is given per annum is the same as the compounding period. That is an effective rate. Yes, Shisana. Okay, so an effective rate could also be something like this. Like, let's say it could be, an effective rate could be something like 1% per month, compounded monthly. That would be an effective rate. Okay, so an effective rate is when the interest rate that is quoted is the same as the compounding period. Okay, and we can use this formula, the one in pink, in order to convert between the two. So if they want us to calculate an effective annual interest rate, they want us to solve for IEFF. Okay, so the 16% will be your nominal rate. So when we sub in here, we would end up with 1 plus 0.16, and M is this. So how often it's compounded. So in this case, it's compounded quarterly. So M would be equal to 4. Pinga, yes. Yes, but no, but yes. Yeah. So an effective rate, so the rate that's quoted is the same as the compounding period. So that could be monthly, it could be quarterly, it could be annually. When it's a nominal rate, the rate quoted or given is different to the compounding period. Okay. All right, and then we just pop that baby into the calculator and we'll see what our effective rate would be. There we go. So that is the same as an effective annual rate, 0.16. And again, I'm going to write down 985856. And then I'm going to remember to multiply by 100. Okay, so that's the same as an effective rate of 16.99%. Okay, so in other words, if we had an amount of money and the interest rate was 16.99% compounded annually, we would get the same amount of money if it was compounded quarterly at 16%. Okay, so you can actually see that. So it's 30,000 Rand. Okay, so if you have a look here, all right, let me just show you how this works. Okay, let's use yeah, absolutely, Pinga. And that's the whole idea is everything is connected. Everything is connected. So you need to see how things are similar and the meaning is the same across different concepts in maths. Nolutando. No, because we're not working with compound interest. Okay. All right. So in other words, so Robin gets, so it's 30,000 Rand, 1 plus, so 0.16 compounded quarterly for a period of 15 years. So this would be 15 times 4. So what does Robin get if we use the nominal rate? Robin gets Robin gets 315588,82. Now, let's compare that with the effective rate that we calculated. I know the question is not asking us to do that. I'm just doing this to help you understand why it is the same. Okay, that's actually answering question B. Okay, so to answer question B, let's see if we get the same or a very similar answer. Okay, they'll tell you, Mihlali. They'll tell you. So here it says, now use the annual effective rate to calculate the future value of the investment after 15 years. By the words future value, they don't mean future value formula. They mean A. Okay, so let's use this rate and answer question B. Okay, so A would be equal to 30,000 is what Robin invests, right? 1 plus, and then this would be 0.16. Let's use this whole number here, 985856. Okay, and then this would be to the power of 15. Okay, because remember, it is an annual effective rate. Let's see if we get a similar answer. We should do 31. And there we go. The identical same answer. Do you see that, guys? Okay. Identical same answer of 315,588 Rand and 82 cents. Okay, so you can see here, even though the question didn't ask us to, I did it for you. I calculated what Robin would have if we worked with the nominal rate. And then you can see when we worked with the effective rate, we got the same answer because we calculated our effective rate correctly from our nominal one. How are we feeling about that? Does that make sense to everybody? Are you okay? Any questions? Pink is happy. How about everybody else? Some P-ware, all right, cool. Kamachelo, Shisana, in between Mihlali. Okay. Chrissy. Okay. So something I often forget to mention, remember you guys have got the Watobe wizard as well that you can use, take screenshots, work through these questions again, use the wizard as a tool to help you. Okay. Or you can come back and rewatch these videos, or you can watch the videos from last year as well. Those ones are also available to you. All right. So let's move on and do the next question. It's getting a little bit more difficult now. Okay. Let's have a look. So Pauline deposits 100,000 Rand into a 5-year savings account. 2 years later, she withdraws 20,000. Calculate the future value of her investment. And again, they don't mean using the future value formula. They mean calculate A. If the interest rate for the first 3 years is 18% per annum compounded monthly and 18% per annum compounded half yearly for the remaining 2 years. Okay, so again, we need to draw a timeline to help us understand what's going on here, right? How long is the money in the account for? I know, Tsechofat, so it's really bad. It's really bad English. They shouldn't say future value. They mean A. They mean A. They just don't mean use the future value formula. Okay, so like I was saying at the beginning of the lesson, how do you know when you're supposed to use future value as opposed to compound interest? So future value and present value formulae can only be used when there is a regular payment. So either a monthly payment or a quarterly payment or a half yearly payment. Right. The amount of money, it's the same thing. X is being paid on a regular basis. All right. Oh, Swanaka, I'm so happy to hear that. That's what we want to do here, okay, is take all these things that have bothered you and you didn't understand why, and just, yeah, fill all the gaps and build you up and make you feel confident and capable, because you are. Okay, cool. I'm glad that you understand the difference between effective and nominal interest rate. That's really cool. Okay, so you're quite right. Who was it? Somebody did answer my question. Nolutando said 5 years. Kamachelo says 5 years. Quite right, 5 years. Okay, so we've got T0, T1, T2, T3, T4, T5. She deposits 100,000 Rand. So that means we've got plus 100,000 Rand in, whoopsie, is that one too many zeros in the beginning? And 2 years later, 2 years later, she withdraws 20,000. So minus 20,000. Okay, her interest rate for the first 3 years, 1, 2, 3, is 18% per annum compounded monthly. And the interest rate then changes to it's still 18%. It's just compounded differently. So it's 18% compounded half yearly. So that's 0.18 divided by 2. Okay. So we've drawn our timeline that we know we're not going to get any marks for, but it just helps us to understand what we are writing when we write our formula, okay, or our equation for A. Okay, so 100,000 Rand is being deposited. Okay, now what you've got to think, or what you've got to understand here is that 100,000 Rand stays in the account for 5 years. All right, treat the withdrawal of 20,000 as a separate term. Okay, so in other words, the 100,000 grows at 18% per annum compounded monthly for the first 3 years. So this will be 12 times 3. The interest rate changes, so we multiply. Okay, 1 plus 0,18 over 2, and then that is going to be for 2 years. So that's what the 100,000 Rand would be worth if there were no deposits or withdrawals after 5 years. Okay, Katlego, go for it.
Ma'am,
Mm.
can you please explain this? I don't know how to ask it, ma'am. But ma'am, why do we multiply, not add? That's the
Oh.
question that Pamela is also asking.
No, that's no problem. I'll answer that with pleasure. Okay, all right, I'm going to do that right now. Over here, we would minus the 20,000. All right, and let's just put that in the 20,000. Okay, so let's just talk about. I'm going to leave that as it is, and we'll come back and fill it in. So you want to know, why am I multiplying over here? Okay, think about it like this. Okay, you would have done this in 2 steps, and you would have got the same answer. So in other words, if I didn't tell you about the 20,000 Rand that came out of the account, and I just said to you that 100,000 Rand went in, it first earned interest at 18% compounded monthly, and then 18% compounded half yearly, you could do it in 2 steps. So you would go A equals the 100,000, and it would be 1 plus 0,18 over 12, and then you'd go 12 times 3, and then you would work out what A is, and you'd round your answer to 2 decimal places. You'd end up with an A value of 170,913, comma, and I'm just going to leave all the decimal places there so that we get the most accurate answer. Then you would do the second part of the calculation. So now the money stays in the account. That 170,913,9538 stays in the account, Katlego. Okay, it becomes the new P value. So now you've got 170,913,9538, and now it's going to earn interest at the new interest rate. For 2 years. Okay. And you would end up with an answer of 258,99. Okay. So instead of doing it in 2 steps and wasting a lot of time writing things that are unnecessary, I'm doing it in 1 step, Katlego. Okay, so if you on your calculator work out the value of this that I'm drawing the black block around, work out the value of that on the calculator, you're going to see it's the same as this. Okay, do you want to ask something else, Katlego? You're welcome to unmute.
So basically, ma'am, what's this? So, okay, ma'am, it makes sense because the answer that you got first, ma'am, it turns into P for the rest of the, okay, ma'am. Makes
Exactly.
sense. Thank
Exactly.
you, ma'am.
Exactly. That's exactly it. Okay. So the answer that you get turns into the P for the next part of the sum. So this is the important thing, Katlego. When money is staying in the account and the interest rate is changing, that's when you are going to multiply by a new bracket. If money is deposited in the account, it will be a separate term. Remember, terms are separated by plus and minus signs. So it will be a separate term with a plus. And if money comes out of the account, it will be a separate term like this one over here with a minus. Does that make sense to you? So that's how you will know the difference between whether you are supposed to be multiplying, adding, or subtracting. Adding and subtracting are for deposits and withdrawals. You times by a new bracket when money is staying in the account and your A becomes your new P. Okay, so I've tried to emphasize that now for you. Okay, hopefully that makes sense to everybody. Okay, so I'm going to rub this out because remember, you are under so much pressure in exams. You don't want to write more than is necessary because you want that time to be able to focus on problem solving and complex questions, things that you need time to think about. So if you spend your time on the easier questions writing more than you need to, that's where time becomes a problem for you in answering an exam. Okay, so that's why I'm showing you these shortcuts. Okay, so you can get to the answer quicker and have more time for the things that actually require it. Okay, so let's just finish this off. Okay, so when the 20,000 Rand comes out of the account, she's not just losing the 20,000 Rand, she's also going to be losing any interest she would have earned on that money because it's not there anymore. So she can't earn interest on it. Does that make sense? Okay, so the money, the 20,000 comes out, but she also loses any interest she would have earned on the money because the money is not there anymore to earn interest. Okay. All right, so now looking at our timeline, where's my pen gone? Okay, again, we have a change in interest rate. So for 1 year, so from here to here, the interest rate is still the old rate, but then it changes. So again, when the interest rate changes, we are going to multiply. So the first thing that we're going to do here, let's write in dark blue, is 0.18 over 12. Okay, it's just 1 year at that rate. Okay, I'm going to repeat that. It's just 1 year at the old rate. Okay, so this is going to be 12 times 1. And then she's also losing the interest at the new rate. Okay, and that would be for 2 years. Oh, sorry, it's not divide by 4. Sorry. It's not quarterly. It's divide by 2. And that would be for 2 years from T3 to T5. So that would be 2 times 2. Okay, so that's how we would actually work out what's her name, Pauline, would have at the end of 5 years. So now you just got to put that all into your calculator. Your calculator is probably not going to be able to take all of that in one go. So what I always tell my grade 11s and matrics to do at school is this: put in the first term first. and then press equals. Okay, and then put in your second term after that. And do that in 2 steps on the calculator. Okay, and then your calculator shouldn't have a heart attack because its memory has been stretched to beyond what it's capable of. Okay, let's just work out the answer. Okay. I got a different answer, Kamagelo. So, Tegofatso, I can do that the next time that we are together. We've run out of time now. Yes, and I mean, the other thing that we also need to be able to do is work with fractions. So, like, they could make a withdrawal after 36 months or 3.5 years or something. So that's also what we're supposed to be able to do. Okay, that's what I'm getting as well. Okay, so Kamagelo is getting a different answer to you, but I'm getting the same answer that Katleho and Shania, I hope Shania, I hope I pronounced that correctly. I tend to butcher names. Masindi, yes. Yes. It's okay, Kamagelo. You don't ever have to say sorry. Never ever have to say sorry for trying. Okay. All right. So I'm getting 207,504,74. Okay. All right. If you want to try something, anybody who's interested in a little bit more of a challenge, you can take a screenshot of this question